Okay, so let's start coding interpretable models. As usual, I'll be importing some of the libraries. And in this notebook, I'll be using the Titanic dataset. I've also done some of the pre-processing here, such as the train test split, encoding, and imputation of null values, taking into consideration the data leakage as well. So I've done this correctly, of course. Now let's discuss interpretable models. And the simplest approach is to use models that are inherently interpretable. And common examples of that would be linear regression, logistic regression, and decision trees. So for linear model, this is very good because it's very straightforward. And these models have been used by statisticians and data scientists for decades. And the relationship is essentially y equals mx plus b. But do take note of the assumptions for linear regression, such as linearity, homoscedasticity, normality of errors, and multicollinearity. Interpretation is very straightforward because every 1 unit increase in if each x sub I, the predicted outcome changes by beta sub I. For this notebook, though, we will be using logistic regression since that is the classification version of the problem, but the same concept still applies. So I've done some scaling here first before I trained it. And I've printed out the score, it's 81%, but I also printed out the coefficients. I did the scaling so that we uh, have the same unit because originally the data set would have varying scales. Could be thousands, millions, some would be decimal. So by standardizing it using the standard scaler, the contribution will more or less, or the weights, or the value, the scale of the values would be in the same range. Now, I've printed out the coefficients. You can see the impact that it has to the output. And that's how we check the feature importance. But I've also done some data manipulation here. So we could clearly see the ranking. I've created a visualization here, using bar graph. You can see that the top predictor is the sex, followed by class, age, and others. So generally having a high sex male value, which essentially means that the person is male, negatively impacts the survivability of the specific person. So generally, that's how it goes with all other features except fair here. Basically, if you have a higher fair, then that's better. For the rest, it's bad if you have higher value. Yeah, as you can see, if the sex is male, the survival rate decreases significantly. Another model that we could use for interpretability purposes is tree-based model, like decision tree. A decision tree splits a database on certain feature thresholds, forming subsets until reaching terminal nodes or the leaf nodes. So we've trained the model. Interpretation is very straightforward. We start at the root node here. And then based on the value that it has on that specific feature, we'll go to the left or the right branch, and you can see the class that it will have. And then just keep on following the if-else rules up until you get to the leaf node, and that will be your final prediction. And you could also explain this again to non-technical stakeholders or audience. So how do we check the feature importance? It is determined by how much it reduces the impurity across all splits that use that feature. And the importances are normalized to sum to 100%. And you could use the built-in feature importances attribute of the model here in scaling. So you can see that still the top predictor is sex male. And that's the output which I visualize here. And that's it for this notebook session.